In this video, I'm going to be covering what's new in NVIDIA Virtual GPU July 2020 release, otherwise known as vGPU 11.0. The first thing I want to talk about is cross-branch support. We introduced the foundation for this in vGPU 10, but cross-branch support now gets fully implemented. Now we have version 11. As most of you will know, there are two main components to vGPU, a GPU manager, which sits in the hypervisor, and a virtual machine guest driver, the software driver you install into the Windows or Linux VM. If you want to mix and match versions of vGPU in the same release branch, say to pick up some new fixes, then that's been supported for some time. However, if you wanted to move up to a brand new version of vGPU, maybe to support a new hypervisor or for a new feature, then you needed to upgrade both the GPU manager and the VM guest driver at the same time. Now, a lot of customers manage dozens of builds and take months to test and QA them, so each new version of vGPU meant recertifying each image all over again. With vGPU 11, we still support in-branch mixing, but now we have the ability to upgrade to a new version of vGPU on the hypervisor while continuing to support the previous version of vGPU on the guest VMs. This makes it much easier to stagger the upgrade process and use a schedule that works for you. Also, like we did with vGPU 8, we've designated vGPU 11 as a long-term service branch, which offers you 3 years of continuous support. This means the choice is yours. You can get new features quickly with our new feature branches, or you can use our LTSB releases to get new features and maintain a consistent environment for a longer period of time. So another thing we've done in vGPU 11 is listen to our customers, and we've relaxed the licensing restrictions that happen in the event of a license server outage. Before vGPU 11, there were two scenarios. If a VM successfully checked out a license at boot, but then the license server went down afterwards, then you had 24 hours of grace before we would degrade the user's experience with 3 frames per second maximum, CUDA restrictions. However, if the VM couldn't find the license server at boot time, it would degrade immediately to an unusable state. Starting with vGPU 11, we've introduced a stepped approach to this. If the VM boots and can't find a license server for some reason, for the first 20 minutes we have no restrictions at all. It'll behave as if it had successfully checked out a license. Between 20 minutes and 24 hours, we start to restrict performance by limiting frame rates to 15 frames a second and introducing a wait time on CUDA processing. This will alert the user that something isn't right, but this restriction wouldn't normally be tight enough to stop them working. After 24 hours, we then go into full restriction mode as before. Of course, with a successful GPU checkout at boot time, you still get 24 hours before things start to be restricted. So a lot of you will be familiar with NVIDIA's Cloud XR SDK, which allows our partners to deliver VR and AR experiences from a virtual desktop to any device. One of the barriers to deliver these workloads was the frame rate limits that apply to traditional VDI desktops. Now, VR workloads not only need high resolutions, but also at least 90 frames a second to avoid the whole experience being laggy and making people sick. So in vGPU 11, we've now provided support for up to 120 Hz VSync at 4K to allow our Cloud XR partners to give users a smooth and immersive experience. Now, I'd like to also mention a couple of things that we've been working on with VMware. Not strictly speaking part of vGPU 11, but things that have been recently made available. Now, many of you will be aware of VMware's DRS or Distributed Resource Scheduler. Recently, VMware added DRS support into vSphere 6.7 Update 1 for initial placement of GPU-enabled VMs. Now, vSphere 7 introduces a new feature called Assignable hardware, which further enhances initial placement. If a VM has a specific GPU profile, DRS will work with initial placement to find a host that has exactly the right profile or GPU available before powering it on. As well as virtual GPU, this also works for PCI pass-through devices with something VMware call Dynamic Direct Path I/O. Another great thing about Assignable hardware is that it also works with VMware's high availability. So if a host fails for any reason, a GPU-enabled VM can be automatically restarted on another host with the right GPU resources. There's a great video that goes into this in more detail from VMware. I've put the link to this video in the description below. Another thing that we've been working on with VMware is an updated version of our management pack to support vRealize Operations 8, or VROps 8 for short. That's out now on our software download portal. Finally, I just wanted to mention that, as always, we've topped out this release with added support for new operating systems and hypervisors. See our What's New section in our documentation for full details. Also, we're working to widen our support of the KVM ecosystem by adding support for SUSE Linux Enterprise Server into vGPU. Stay tuned for more on that later on in the year. So, I hope you've enjoyed this video. If you want to download vGPU 11, head across to our licensing portal here.